Did you know that there's this thing called RF shielding that goes into an MRI room? It's actually quite interesting. It's basically a room inside of a room. Hopefully by the end of this speech you'll understand what's planning that goes into this, why it's needed, and how it's built. First things first, why it's needed. So RF shielding is needed inside of an MRI room because it's going to help your MRI machine provide a clean image when it's scanning a person or an animal. Yes, that's right. An MRI can be used to scan a person or an animal. That being, it just depends on what it's being used for. If it's used for scientific studies or main hospital where it's scanning for cancer and things of that nature. Now, let's talk about what's going into the planning. In planning for an MRI room or planning for the RF shielding of the MRI room, you need to understand what type of magnet is going into this room. This is needed because it's going to determine what kind of filtering is needed for this room as well. There are different brands of magnets that I really can't get into because there's so many. But I can tell you they all have a certain filtering and a certain frequency and requirements that they need to meet. Now, once you determine what magnet is going to the room, you need to determine if the 5 Gauss line of the MRI machine is going outside of the room. This is needed to be determined because it's going to determine if there's this thing called silicone steel that will need to be placed into the room as well. Silicone steel helps keep that 5 Gauss line inside of the MRI room. You don't really want that 5 Gauss line to get outside of the MRI room because if a person with, say, a pacemaker walks by, what can happen is it can actually mess up that pacemaker in that person. It's a lot. Once you determine that, and if there's any steel that goes into it, you're going to determine what kind of lighting is going into this room as well, and also where your mechanical is going to route in this room. Now, it's quite interesting with the lighting because it's not your typical lighting. It's called MRI lighting. The reason being is anything that goes into an MRI room is going to be non-ferrous and also has to travel through what's called a waveguide. With the waveguide, that's typically going to deal with your mechanical ducts. What's going to happen is you're going to have your steel or aluminum duct, whatever you're using, run to the RF shielding and connect to the waveguide, and then on the inside you're going to have non-ferrous. Again, because your MRI machine is one big magnet. And you don't want a person to be inside of that MRI machine and there be something metal inside the room and it gets pulled and that person is harmed. Now, once you determine your duct routing, your lighting, and things of that nature, you need to determine the filtering for the lighting. Now, everything that's going inside of an MRI room is powered by a filter. These are single line filters that electricians need to hook up to in order to provide the lighting and different things that the technicians will use inside the room. Once you determine that, next step is to build the MRI machine. And building the MRI machine is quite simple. It's just like putting together a puzzle, except you're using screws. You want to make sure that this is airtight because there's frequencies that you have to keep inside the room in order to make sure that your MRI machine is operating at the proper requirements, so to say, that you need it to be. It has to give you a clean image of the person, and if those frequencies are getting outside of that room, then your images are being messed up. I know there was a lot. I know I stuttered a lot. Glad this is a dry run, and hopefully you learned a little bit about RF shielding and why it's needed.